In this video I'm going to work out an individual integral problem. It's going to be just a straight U substitution, but I am going to maybe show some ways to manipulate the algebra so that you can easily see the parts and things that are going to cross out with that U substitution. So initially here I've got a quotient. I'm going to choose to rewrite that into the product of two things just algebraically so that I can look at this a little bit differently. I'm going to have an e raised to the 1 over x times a 1 over x squared. Alright, so definitely just rewriting that initial expression so that I can maybe more clearly manipulate and work with this equation as we continue on. Alright, now I see there I've got an e raised to a power. Most of the time if you're going to do a u substitution, you're just going to let that u be whatever that exponent is. So that's where I'm going to start. I'm going to say we're going to let u be that 1 over x. Okay, now I need to take the derivative of both sides, so obviously that's going to be a du equals. Now if you struggle a little bit taking the derivative of that 1 over x, you might want to think of it as x to the negative 1. Might make that derivative a little bit easier there, so then it's going to be a negative x raised to the negative 2 dx. Alright, now I don't want to leave it like this because I have an x squared in my problem and this is an x to the negative 2. So I'm going to rewrite that so I have a positive power. So du equals a negative 1 over x squared dx. And then going ahead and solving for that dx, I'm going to multiply both sides of the equation by the negative x squared. So negative x squared du is equal to dx. Okay, a lot of work there, but it's going to pay off then in the end here. Now I'm going to come back up here to this original integral and I'm going to start doing some substituting. We said that our u was going to be 1 over x, so I'm going to have the integral of e to the u and then times the 1 over x squared, and then I'm going to replace that dx with the negative x squared du. Alright, that's going to allow those x squareds to cross out, and it's going to allow me to take that negative and pull it out in front of my integral. So negative pulled out in front, and then I'm integrating e to the u du. Alright, we know how to integrate e to the u. It's just going to be e to the u, so I'll have a negative e to the u and then plus c, and I can replace that u with what I initially let it equal to, so negative e to the 1 over x plus c. So really a straightforward u substitution integration there, except just over here, you know, messing with those exponents, knowing those laws of exponents so that I can maneuver things so that they easily cross out. Definitely, thanks for watching, and don't forget to subscribe to the channel. Thanks.